Yo, let's get going on this quiz review. So the very first thing you should do when you get your quiz is write SOHCAHTOA at the top. That's going to be super duper useful for you while you do this entire dang quiz review. In fact, it's going to make a difference on the very first question, or at least first set of questions here, sine, cosine, tangent. Here we go. An angle formed by an upward line of sight. So you're looking up like an elevator. Letter D, angle of elevation. After that, we have the ratio of the leg opposite to the leg adjacent. So the keywords here, we got the opposite and the adjacent. We have the O and the A. So we have the SOHCAHTOA that we just wrote down. The reason why we wrote that down is for sine, cosine, tangent. Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Tangent is the opposite over adjacent. So when it says opposite over adjacent, we know that it's the O in the A. That's the word tangent. Then we're going to go on to the next one. It says the ratio of the leg opposite to the angle of the hypotenuse. So we have the opposite over the hypotenuse, the O, the H. That's sine, letter A. Then we have an angle formed by the downward line of slope. Looking down is called that angle of depression. And last but not least, the only one left here, we have the adjacent over the hypotenuse. We're going to call that one a cosine. Beautiful. Continuing on, number 6, what is MK? So the key here is if you recognize an angle that has a 45, a 30, a 60, if you have any of those three angles, you know it's going to be a special right triangle, and you have to answer what is called exactly. So really, for all questions 6, 7, 8, and 9, it really should have said exactly. So every single one of these, I am going to be grading exactly. So just a heads up, that's how it's going to be in my class. So when I say exactly, your answer needs to use square roots. Okay, so we're going to use these square roots here. And in order to do that, we need to remember that this is going to line up exactly with our 45, 45, 90 triangle. So our 45, 45, 90 triangle, I'm going to draw an additional one right over here. We have that right angle. We have the 45 degrees. And then our regular 45, 45, 90 is going to have a 1, and a square root of 2. And the idea is to go from this triangle to this triangle. We use that fancy word before that we called the scale factor. We are multiplying by 8. So really all we did was we multiplied from 1 to 8 to get there. We had to do a little bit of extra work. But yeah, basically whenever time you're given one of these legs, you just got to multiply. So you're going by 8. So that means that this bad boy over here is also an 8. And this one's going to be an 8 with a square root of 2. And that's all you have to do. So MK is 8 square root 2. And that is the entire process. There is no real work to be shown on there. However, on question number 7, we have a little bit of a different situation. The reason why we have a different situation on question number 7 is the fact that we're asking a different question here, because from 1 to 8, it's really simple to multiply by 8. But this one, you're asking the question really, how do I get from the square root of 2 to 18? Well, to do that, what you actually have to do is you have to do divided by. So we're going to go ahead and do 18 divided by the square root of 2. However, you're not allowed to leave your final answer with a square root in denominator, even though I really wish that wasn't a rule in the math world, and it's kind of a fake rule anyways. It's one of those things that we have to deal with because that's what people expect. So in order to do that, the actual work for it, I'm going to do the actual work in red, so I don't recommend writing down the actual work because there's a trick to it at the end. But the actual work here is to multiply by the square root of 2 over the square root of 2. You're multiplying by 1. And when you do that, you're going to be getting 18 square root 2 on the top and 2 on the bottom. The reason why you're doing that is the 18 times square root 2, that's itself. And a square root times a square root is going to cancel each other out, and we just get 2. However, I said this part in red you don't actually need to write down to remember, because the trick you can do is the fact that you're taking the square root here and you're moving it to the top. And then on the bottom, you can see that this number is just on the bottom without the square root. So you don't really need to do any work. It's just really just copying, the bottom part goes to the top, bottom part loses a square root. That's it. Last but not least, you have to check to see if there's a division you can do. On this one, you can do 18 divided by 2. That's 9. So you're going to get 9 square root 2. Continuing on, number 8, what is DF? So on these questions, we have a 30, 60, 90 instead. The 30, 60, 90 triangle that we definitely have to have memorized is we have a 30 over here, a 60 over here, a 1. Using an arrow across from the 30, we have the 1 opposite the 30. We have the square root of 3 opposite the 60. And then we have a regular 2, not a square root of 2, opposite the right angle, that hypotenuse. So the deal is here is they're trying to trick you with the square root of 3 kind of like in the wrong position. So to go from this triangle to this triangle, we have to multiply by 5 times square root of 3. So you're going from here to here, you're doing 5 multiplied or 5 square root 3, you're doing 1 times 5 square root 3 to get to this side over here. So for here you can do 5 square root 3 times square root 3. So df is going to be 5 square root of 3, and then you're multiplying by that square root of 3. When you get that, the square root of 3 times the square root of 3 is just 3. So we're going to have 5 times 3, which is 15. As for EF is that longer side. That one's going to be 2 times 5 square root of 3. So EF, that's going to be 2 times the 5 square root of 3, and that's going to be 10 square root of 3. Continuing on, let's move on to question number 10 here. Which leg is opposite angle C? Remember, what you're going to do is you're going to be taking that pencil, you're going to draw all the way across. So what is all the way across over there is AB. As for adjacent, adjacent means next to, not hypotenuse. So we have next to, not the hypotenuse. So next to that is not the hypotenuse is this one right there. That's going to be BC. Those are nice, easy questions. Let's go to the back side now. Over here, the first thing I'm going to do is I'm going to write SOHCAHTOA at the top of my page so I can remind myself what that is. Once you're really, really good at it, you actually don't need to write this down every time, but some students actually continue writing it down over and over forever and ever just because it helps them, you know, figure out what they got to do. So sine of R here, remember R is this one up here, so you're going to be kind of pointing across. There's our opposite, there's our adjacent, there's our hypotenuse. The sine of R is going to be the opposite over hypotenuse, 24 over 25. The cosine here is going to be the adjacent over hypotenuse, 7 over 25. And then we have the opposite over hypotenuse, or sorry, opposite over adjacent. Man, I spoke that wrong. Opposite over adjacent for the tangent, it's going to be 24%. Okay. Number 15, what is HG, the nearest centimeter? So this one, you have to round to the whole number, kind of interesting. So you're rounding to the whole number here, and you're figuring out what is HG. So you're trying to figure out this right here. This is X. So using our same exact idea from the previous problem, we're going to have like draw a little arrow going out over here. That's going to be our opposite side. The side that's not next to the right angle is a hypotenuse, and then this side is going to be our adjacent. So we are given in this question, we are given this letter X here. We're given this number 40. We are not given anything down here because we are given the O and the H. Our O and the H is S for sine. So we're going to go ahead and write down that we have the sine of 37 degrees is equal to, we have the opposite over hypotenuse, that is X divided by 40. To solve a question that looks like this, we're going to take that 40 and move it up to here. So we have 40 multiplied by the sine of 37 degrees. That is going to be what X is. And now to figure out the answer, we have to use a calculator. Now these calculators, if you have one of these nicer ones that has the color, you can see up here this word radian. You cannot have it say radian. It must say degree. So if it doesn't say the word degree, you need to change the calculator to degree mode. In order to do that, you're going to hit the mode button. After you hit the mode button, you need to go find where it says degree. And degree has to be highlighted. Now we're going to quit back by hitting second quit. And now we're going to type in the question just like it appears here, 40 times the sine of 37. And we're going to get the correct answer there of 24.07. But it didn't say the nearest centimeter, so we're just going to say that X is approximately 24. Probably put the centimeters to make some physics teacher happy. All right. After that, we have FG. What is FG to the nearest centimeter? So now we're trying to figure out this side over here. I guess I can label this one the letter Y. So now I have the A over H, which is from the top of the page here. We got CAH, SOHCAHTOA. So cosine. So we can say the cosine of 37 degrees, that is going to be y over 40. So this one's going to be 40 times the cosine of 37 degrees. That's going to be y. Or in other words, y is approximately what? I don't know. I'm going to type it in my calculator off screen here. 40 cosine 37. Turns out that it's about 32 on your centimeters there. Moving on to number 17. What is the measure of angle T to the nearest degree? So we need to figure out what is theta over here. So just like before, we're going to label these things up. So going over here, there's our opposites. Here's our adjacent, and here's our hypotenuse. Remember the hypotenuse side, the right angle doesn't touch. Adjacent means next to, but not the hypotenuse. So here we clearly have the A and the H. So we have cosine again. Cosine of theta is going to be equal to 3 over 8. Because the cosine of theta is going to be equal to 3 over 8, that must mean that theta is equal to, what you're going to be doing is you're effectively, the way I like to imagine it is you're taking cosine to the other side of the equation. When you change cosine to the other side, like when you're doing like 5 to the other side, it might become -5 on the other side. This one's going to be cosine with a -1 on it. We call it cosine inverse. So we're going to go ahead and write cosine with that little -1, 3 over 8. And again, the way that you say that out loud is cosine inverse, or the inverse of cosine. And maybe even later on, you'll learn what is called the arc cosine, which is pretty much exactly the same thing. We'll call it the same thing for this class. And then we're going to go ahead and do, and calculus teachers don't kill me for that. All right, cosine inverse of 3 over 8. I do know the difference. We're not worrying about it right now. 60, nearest degree, so 68, I guess. That's what they want us to write. So theta is approximately 68 degrees. Okay, what is the measure of angle W to the nearest degree? So this one over here, we're going to go ahead and call this guy alpha. Now, there's our alpha right there. So our alpha, I'm going to use a different thing because now when I go across over here, now this side is my opposite, this side is my adjacent, and now this side's my hypotenuse. So now I have the 3 over 8. I have sine instead. So I can go ahead and say that the sine of alpha is going to be equal to, and then we have 3 over 8, and likewise alpha is going to be equal to, sine inverse of the 3 over 8, which is approximately what alpha is. I didn't show on the calculator where the cosine inverse button is. Cosine inverse is right above the cosine, so you can kind of see it right there. So sine inverse is going to be in that same spot. We hit second sine inverse 3 divided by 8, end the parentheses, and we're going to get approximately 22. And any of the astute students might have noticed that, hey, Mr. Richards, you just wasted your time. I sure did. Because what I could have done, if I was being smarter about it, was going on over here, and I could have said, hey, I know that alpha must be equal to 90 minus theta. It must, in fact, be equal to 90 minus 68 degrees to get that 22. So you could have easily just done that. However, I wanted to show that trigonometry work for sure. All right, number 19. If the angle of elevation from the bottom of a slide to the top is 47 degrees. So you're on a slide here. You get your slide, and the angle from the bottom to top is 47 degrees. Okay, and the slide is a vertical height of 14 feet. So let's drop a side over here that's 14 foot. What is the length of the slide? So that's going to be this side over here. That's going to be our triangle that we're making up here. So just like the previous ones, kind of want to draw your little side over there. So drawing it over here, we have the opposites, we have the adjacent, we have the hypotenuse. I didn't even draw that all the way in there. Our right and our right angle, and therefore we can write down that we have the sine of 47 degrees is going to be equal to the opposite over hypotenuse 14 over x. Now, the big difference between this question and questions numbers 15 and 16 is that x is on the bottom. When the x is on the bottom, you switch the positions of the x and the sine. So we're going to go ahead and say x is equal to 14 over the sine of 47 degrees. And again, we do need to plug it into, and it says to the nearest foot, so we're not even doing any decimal places. How weird. I'm following along with what they're telling me to do, though. So we have 19.14, which is 19, apparently. We're going to do 19 foot long. It's a pretty big slide. It's a solid 3 or 4 people length. All right. A dog is standing 3 feet from the base of a tree, looking up at a cat that has climbed 21 feet up the tree. So here is my beautiful tree. There's my tree. And the dog is standing 3 feet away there. And he climbed 21 up. What is the angle of elevation? So the angle of elevation is this one right here. There's my theta. And we can go ahead and, just like before, we can draw or write it out, that tangent equation. The tangent of theta is going to be the opposite over the adjacent. You could have just made it easy for yourself and written 7, by the way. 21 over 3 is 7, so you could just do that. I'm going to just not simplify it because laziness overtakes there. But 21 over 3, I guess I could just write, I'll just write 21 over 3 again. That's fine. Doesn't really matter. Because laziness would be writing only the 7, right? Anyway, so second tangent inverse of, I'm just gonna write the 7 here, though. That's the laziness we need right there. All right, so theta is approximately, and is it to the nearest degree again? Yep, to the nearest degree, we got 82. It's beautiful. All right, I'm all done, guys. Have a great rest of your day. Peace out.